Alright, let's get into it. So, I am doing my second derivative video. Tangent x e to the tangent x ln of cosine of x. And then sine of cosine of square root of x. And then ln of x plus 1 all raised to the fifth. Let's do it. So, 1 d over dx of tangent of x. Well, I can rewrite that as the derivative with respect to x of sine of x over cosine of x. I know I don't sound very riveted or excited at the moment. I'm sorry. That's probably something that I should be doing right now. So, well, this is the quotient rule right now. So, to do the quotient rule, it's just like the product rule, except there's a minus sign in between. And it's divided by the original function squared, and I'll show you, like the bottom function that's original squared. And I'll show you what I mean by that. So, we take the derivative of the top, so that's cosine of x, and then we multiply it by the other term, which is just cosine of x, and then we subtract. Now, we take the derivative of the bottom, and that's the derivative of cosine is negative sine of x, and then we multiply it by the top, so that's sine of x. And that's all over, just like I said before, the original bottom function squared. So it's all over cosine of x squared. And this is the same as cosine squared x, but because I have two negatives, it becomes a plus. So it's plus sine squared x all over cosine squared of x. And this actually just evaluates to 1 because this is the most famous trigonometric identity, cosine squared x plus sine squared x equals 1. So that's just 1 over cosine squared of x. But the story doesn't actually end there. The final answer is just secant squared of x. Alright, next one. Let's get into it. So, number 2, that's e to the tangent of x. Well, let's write that we're taking the derivative of e to the tangent x. You remember from the last video, I'm trying to hammer the point home how a derivative of an exponential is done. So we just found out the derivative of tangent of x. That's why I've chosen this one. So we know that the derivative of tangent of x is secant squared of x. This is secant, by the way. SEC is short for secant. So what we do is we take the derivative of the top and we multiply it by the original exponential function. So it's literally just secant squared of x e to the tangent of x. And that's our final answer. So now let's do number 3. And that's the ln of cosine of x. So the derivative operator, yet again, what does that equal to? Well, the derivative of ln of anything is the derivative of whatever's on the inside divided by the original function. So the derivative of cosine is negative sine of x, and then divided by the original function, cosine of x, which is just equal to the negative tangent of x. I love how I'm using tangents a lot in this video. I've played around with the tangent function a lot. I hope you can appreciate that. So now let's do question 4, which is the derivative of the sine of the cosine of the square root of x. And you'll notice that whenever you're dealing with lots of derivative operations and trig functions, you'll be saying the word of a lot, like of. Anyway, for the derivative operator, yet again, of sine of cosine of the square root of x. And that's equal to, this is the chain rule, 3 times in a row. So the derivative of sine is cosine. So we take the first part, we work from the left to the right. That's what we do. So the derivative of sine is cosine, and then we rewrite the original function as it used to be. Now we start from the cosine part. So the derivative of cosine is negative sine. And then we keep the original part alone again. And now we can finally finish by taking the derivative of the inside. So we've taken this part, the derivative of that, we've kept, and then we've multiplied it by the this by itself, and then we've started from here. We take the derivative of this, we leave this alone, and now we're up to the step where we can take the derivative of this. And we know the derivative of square root of x. That's just 1 over 2 square root of x. And if you don't believe me, you can justify that to yourself by taking the derivative of this. And it's literally just the power rule. Alright, so that's the final answer. Alright, last one. That was the ln of x plus 1 all raised to the 5th power. So let's finish off the video with a banger. Not really, it's not that hard. It's actually easier than the other ones. So what's the derivative of this? Well, it's the chain rule, right? Outside, inside rule. So we would say that this is equal to 5 ln of x plus 1 to the 4th power. And then we multiply by the derivative of the inside. And we know the derivative of 1 is 0. And we know that the derivative of ln of x is 1 over x. And that is our final answer. Obviously nothing's been like, you know, algebraically cleaned up or anything, but that's pretty much the gist of it. So that's the end of the second derivative video. Thanks for watching. I'll see you in the next one. As I said, I'll make 5 derivatives per video and I'll try and make them interesting. See ya.